Hello everyone, this is Pragya Shaha and I am back with another book review. So now this book review is going to be about a structural geology book. Structural geology, very basic books, very like something that is considered to be a textbook. So this is the book, heavy duty hardcover book, very important book, Twiss and more. So we'll quickly go through the contents. There is nothing wrong, like negative about this book. Everything is just so basic and everything is just so perfect about this book. It's intimidating at times with them. If you are afraid of mathematics, then you can get intimidated with the structural geology, because there is a lot of calculus involved and a lot of other types of higher level mathematics. But this is a beautiful subject when it comes to the deformation history. When it comes to the understanding the rock deformations, then the structural geology is the subject that you read. So let's quickly go to the contents. I will talk about the introduction first. So what are structural geology and tectonics? Structural geology, tectonics, and the use of models, the interior of the earth and of other terrestrial bodies, the earth crust and plate tectonics. Introduction. Ocean basins, the structure of continental crust, Precambrian shields, Phanerozoic regions, summary and preview. Brittle deformation, we have fractures and joints, classification of extension fractures, geometry of fracture systems in three dimensions, features of fracture surfaces, timing of fracture formation, relationships of fractures to other structures. Introduction to faults. So types of faults, recognition of faults, determination of fault displacement, fault geometry, balanced cross sections. Summary and preview. Normal faults, characteristics of normal faulting, shape and displacement of normal faults, structural associations of normal faults, kinematic models of normal fault systems, determination of extension associated with normal faults, thrust or reverse faults, recognition of thrust faults, shape and displacement of thrust faults, structural environments of thrust faults, kinematic models of thrust fault systems, geometry and kinematics of thrust systems in the hinterland, analysis of displacement on thrust faults, strike slip faults, characteristics of strike slip faults, shape, displacement and related structures, structural associations of strike slip faults, kinematic models of strike slip fault systems, analysis of displacement, balancing strike slip faults, stress, force, traction and stress. The Moore diagram for two-dimensional stress, a terminology for stress of state of stress, a closer look at the Moore circle for two-dimensional stress. The stress tensor. Okay, now here we have a lot of information, like what is a vector, brief review, more diagram for three-dimensional stress, what is a tensor, sign conventions galore, a cautionary note, derivation of principal stresses in two dimensions, mechanics of fracturing and faulting, experiment and theory, experimental fracturing of rocks, fracture criterion for tension fractures, the Coulomb fracture criterion for confined compression, effects of confining pressure on fracturing and frictional sliding, effects on fracturing of anisotropy, the intermediate principal stress, temperature and scale, limitations of the Coulomb fracture criterion, the Griffith theory of fracture. Okay, Coulomb fracture criterion in terms of principal stresses, mechanics of natural fractures and falls, elastic deformation, techniques for determining stress in the earth, mechanisms of stressing the earth's crust, stress in the earth, stress histories and the origin of joints, the spacing of extension fractures, distinguishing extension fractures from shear fractures, fractures associated with faults, fractures associated with folds, stress distributions and faulting, the mechanics of large overthrusts, cause and effect, a word of caution, ductile deformation, the description of folds, geometric parts of folds, fold scale and attitude, the elements of fold style, the order of folds, common styles and structural associations of folding, for foliations and lineations in deformed rocks. So tectonites, compositional foliations, disjunctive foliations, crenulation foliations, continuous foliations, the relationship of foliations to other structures, special types of foliation and nomenclature, structural lineations, mineral lineations, associations of lineation with other structures, geometry of homogeneous strain, measures of strain, the state of strain, special states of strain, progressive deformation, progressive stretch of material lines, homogeneous and inhomogeneous deformation, the representation of three-dimensional strain states and progressive strains, tensor representations of strain, finite strain of an arbitrary line segment and the Mohr circle, application of strain analysis, kinematic analysis of folds, flexure folding of a layer, passive shear folding of a layer, volume loss folding of a layer, inhomogeneous flattening of folds in a layer, folding of multi-layers, formation of kink and chevron fold, fault bend and fault propagation folding of a multi-layer, drag folds and Hansen's method for slip line determination, superposed folding, diapiric flow, analysis of foliations and lineations, material and non-material foliations and lineations, mechanisms of formation of foliations and lineations and their relationship to strain, interpretation of the morphological types of foliation, steady state foliations, foliations and shear planes, interpretation of morphological types of lineation, lineations on folds, observations of strain in deformed rocks, measuring strain in rocks, relationship of strain to foliations and lineations, measurement of strain in folds, strain in shear zones, deformation history. Rheology. Okay, continuum models of material behavior, experiments on friction and cataclastic flow, implications for faulting, experimental investigation of ductile flow, steady state creep, the effects of pressure, grain size, chemical environment and partial melt on steady state creep, application of experimental rheology to natural deformation, mechanisms of low temperature deformation, twin gliding, diffusion and solution creep, linear crystal defects, the geometry and motion of dislocations, mechanisms of dislocation creep, microstructural fabrics associated with dislocation creep, preferred orientation fabrics of dislocation creep, symmetry principles in the interpretation of deformed rocks, scale models and quantitative models of rock deformation, constraints on physical models, the theory of scale models of folding, scale models of gravity driven deformation, plastic line, slip line, field theory and faulting, analytic solution for the viscous buckling of a component layer in an incompetent matrix, numerical models of buckling and the effects of different rheologies, regional associations of structures, divergent margins, development of structures on active plate margins. Now, divergent margins on the continents, continental drifting, divergent margins on ocean basins, major strike slip faults, transform faults and mega shears, convergent margins, active collisions. Anatomy and tectonics of orogenic belts. Introduction. The foredeep or foreland basin, the external thrust complex, foreland fold, and thrust belts, late belt, ophiolites, and structures and sutures. The crystalline core zone metamorphism, the crystalline core zone structure and lithology, extensional deformation and low angle detachments, high angle fault zones, minor structures and strain in the interpretation of orogenic zones, tectonics, topography and erosion, tectonics and metamorphism, a simple model Simple models of orogenic deformation, a two-dimensional plate tectonic model of orogeny, the Wilson cycle and plate tectonics, terrain analysis, the orientation and representation of structures, the attitude of planes and lines, graphical representation of orientation data, geologic maps, cross-section portrayal of structures in three dimensions, geophysical techniques, seismic study, analysis of gravity anomalies, geomagnetic studies, units and constants, basic SI, table of SI multiples. Okay, I'll not go through the appendix tables. There are a lot of tables. Okay, certain things are important like sign convention for stress components, stress interpretation for fractures in folds. Okay, tightness of folding, aspect ratio, elements of fold style. These things, tables are important, appendices are important. This is a very classic book, so there is not much negative about this book. The diagrams, and it's structural geology is a very diagram based subject. A lot of diagrams you will get to see. Okay, the page quality is nice, the font shape is nice, a lot of diagrams. You will get a lot of atlas from Shomojit Mukherjee sir from IITB. I will review those atlases as well. So yeah, a lot of mathematics, a lot of diagrams, pictorially very beautiful subject. You can see the cover of the sub book, it's beautiful. It's this is a fold. What type of a fold is this? Which has also got a faulting. I have to check out what kind of a folding and faulting is this. This is the subject, structural geology. I have started structural geology series. Hope you like this video. Stay tuned for more. Until then, tata.